Hello, and thanks for having me. Yeah, Neo4j for Java developers. 30-minute time. There's plenty we have. So let's get over it. First of all, yes, I'm Gerrit Meier, as introduced, working at Neo4j. Main focus is Spring Data Neo4j, object mapping, and the Neo4j object mapper itself. If you want to reach out later to me, meistermeyer.com is a blog where I, from time to time, post something. Otherwise, on Mastodon, you can find me. And in my spare time, I'm the leader of our local Java user group here in my hometown. So let's get started. Everything I will show you today is easy to reproduce. There will be also a link to some examples that you can just follow up on the things you've just seen. So it doesn't matter if you're running your server as a binary somewhere or Docker image, or you have Docker desktop and Neo4j desktop installed, or even on one of those cloud vendors. But of course, the easiest way to run Neo4j is always to go to Neo4j over free. And before we now just jump into the code, and you see a few examples. If you have any questions, please use the Q&A tab or write a chat message or something. I will try to manage my time well so that we have maybe 5 minutes left at the end, and I can answer the questions if they are quick to answer, and you can get some, or all the others who are attending the session will benefit from those informations. All right, so today we start with just looking at drivers. Then we look what we can build upon the driver itself, and then some tools and libraries you can use adjacent to your Java application most of the time. And as always, we need some foundation. So today's graph is not fancy 2 million nodes and 4 million relationship graph, but it's the graph you will get with every Neo4j binary installation that you can create when you do the play movies example. So we have the movie graph, and this is just a subgraph of the movie example, where we mostly focus on today, so that you can see that we have reproducible results in various technologies or libraries. This is now concentrated around the actor Lawrence Fishburne. So we just want to find out on various ways who, if we can find him and in which movies he acted in. So without further ado, let's jump to the lowest abstraction we have for accessing data from your application, Java application side. So of course, Java driver. As you might know, we have those drivers with this 90% the same functionality, also for Python, JavaScript, Net, and Go. And there will also be some Python driver with a Rust extension, so you can use this. We have community drivers for Rust that are not officially supported, but if you are missing your language here, feel free to ping us in our community forums or similar, or Discord. So with the driver, I think most of you who has used Java and Neo4j in the past knows this pattern. We create our driver instance. We now, since Java 5, we have this method where we can just create a query directly from the driver object. So you don't need to open a session first or a transaction, but you can use this executable query method to execute your query. Some words on this. So this is a kind of magic function. If you do, for example, driver session 1, it is really problematic in some cases where you run with clusters, etc., that might not be stable, or network might not be stable, that you might run into timeouts, or the server went away, or similar. But with the driver executable query, you get all these retry mechanisms free. So when you're running, for example, you're just a beginner with Java and Neo4j, and you see, oh, the first time Java driver code. Also, it's a good advice if you for example, started your Aura free instance, use those methods if you want to interact with the database on with your first steps. And then I think it's just Java, verbose as it is, but then we just gather the results and print them out. So we get a nice list of all the actors that we have with all their movies they are acted in. And I think the result shouldn't be surprising. So we really get this list. And this is nice because this was our first way into the database to retrieve some data. In general, today we will speak more about data fetching because it's an interesting bit. It's not so it does not need so much code as, for example, writing and looking at problems and what might happen in data types. But we are just consuming data now from the database. So, So if we want to filter for some particular actor, Lawrence Fishburne, for example, we can add some clauses or conditions where we say, okay, we want to have the actor's name matching the name from a parameter that we provide. So we can extend the method execution by one method more, and we provide then this property. It will get used as a condition, and then we get the result only for Lawrence Fishburne. So this all is nice. You have a driver, you can use it. You have maybe a vanilla Java application with some maybe dependency management going on, and that's good. But that's not what we're facing most of the time. We are facing enterprise frameworks, if you want to call them so, application frameworks, dependency injection. And the good news are the driver is not only available, of course, because it's Java, for all those frameworks. No, but if you throw them as on the driver on the class path, you can get out-of-the-box support for Spring, Micronaut, Helidon, and Quarkus. And that's pretty much what we try to do or to achieve here, is to provide you the same syntax for most of those frameworks. Maybe, of course, if you have a Spring prefix, you won't see this in a Quarkus application. Some, like Helidon and Micronaut, don't even need one. But you can see the pattern, I think. And then you get the benefit of getting a pre-configured driver. So those three properties you see at the top are not the only ones we provide support for configuration, but there's an exhaustive list. And if you look, for example, in the Spring Boot documentation, because it's a Spring Boot auto configuration, that's why this configuration lives directly in Spring Boot, so it's unrelated to anything Spring Data Neo4j or similar. Or in the Quarkus documentation, you can find all those properties listed that we support out of the box. For some frameworks, we also made sure that we support future parameters. So you get also the possibility to add programmatically some beans to your code that will help the driver configuration to add unknown properties that might appear in later versions of the driver. So this is cool. So of course, since I already said this, I developed Spring Data Neo4j. We will now have a look at object mapping, right? So if we have this integration of the driver in Spring Framework and we get a configured driver, you could use it either the way I presented it in these driver slides, or you could make use of the driver and go ahead and go to object mapping. So also same example, same graph, or same subgraph. We want to, in the end, we want to figure out if we can find Lawrence Fishburne with all the movies he acted in. And for this to do, and we want to do object mapping, is as easy as create two records. For now, use records. Of course, you can use classes. So we define a person with some unique identifier, because we all know that names are completely unique. We use it for this example. So we use the identifier for the name. And we want to declare a relationship to those movies the actor or the person the actor has acted in. And at the end of this relationship, we expect a list 0 to n movies that also should be mapped. And so we define the second record here, where we say, okay, also movie titles are unique. Why not? And that's the only property we will now pass from the movie example. And if we have this, we already mapped our whole domain exhaustively. And then we next need to create a person repository. So a repository means that we want to access data within the database via the repository pattern. So some folks who might be more deeper in the domain-driven design than me might say, okay, there's something wrong, but that should be the one thing that you take with you regarding repositories. If you want to access objects, you go over repositories. And it does not mean that you need Spring repositories, but only some access layer. And yeah, with this Neo4j repository that we define also as an interface, you will get find by ID, delete, save methods, of course, also for writing out of the box. But you can also provide your very own queries, but also so-called derived query functions that you see here. So find by name, for example, will look at the person node in a graph and apply the same condition filter that you have seen before with the p.name equals the name that I will provide. We'll create this query and execute it then with this property provided to the as this parameter provided to the query. Okay, if you have looked closely, it's the ID is the name, so it's redundant in this case, but it also works. And with this, you don't need to do any more than saying, okay, I want to call my repository with find by name. arg0 is now, because we're using command line runner and everything, should be also executable for you. I didn't do any exhaustive parsing of those parameters. In this example, it would be the additional parameter to run the program with, so it would be Lawrence Fishburne in this case. And as a result, it just looks fancier because we have used records, so we get the two string methods out of the box. You see the person Lawrence Fishburne with the movie records or instantiated objects of movies connected to him. That's nice, right? So, as you have seen in this example, there were no Cypher. If you have seen the driver example closely, there was Cypher. So some folks like to write, in general, database queries. Some people don't want to. But those people who don't want to, or those people who want to write it but want to write it nice, might make use, specific for Neo4j, of the Cypher DSL. That's something that we came up with when we developed the new version of Spring Data Neo4j. So it was. It's now a very much mature project, but it was more or less, first of all, something that we needed, and that's why we gave this more love than you would have with a hobby project or something, because we wanted to really have this in Spring Data Neo4j. CypherDSL helps you to write Cypher statements in a type-safe way. That does not mean that you can not provide types in the sense of value types somewhere, the wrong or the correct ones, but it's more about what is possible after the next step. So I would create something like a match clause, and then I can only have a condition, for example, or another match, or return. But it will not allow me to go any step, take any wrong step or wrong turn in this way. So if it compiles, it is at least grammatically correct Cypher. If it runs on your database or if it does not find any data, it might be more your problem then. But the benefit of abstracting this pure string that we want to express into a DSL does not only help to write those statements, but it does also help to provide something that we also call, like, for example, I think JPA or Hibernate, it's the same dialects. So if you're an experienced Neo4j user for a long time, you might already know that we from time to time change some functions, not even names, but more or less the functionality. And with this abstraction, we get the chance to throw in dialects. So how do you translate this abstract syntax tree to a string, to a Cypher query string? And for example, we support the element ID function. The element ID function just got introduced in Neo4j 5. But so that you can still have valid Cypher, we try to come up with a substitution. Of course, it's not good for the or great for your index usage, but you will get, for example, to string for ID. So you can at least of ID. So you can be at least sure that you get a string back in this case. And I think that's valuable. So I recap now the driver example that we have seen before with the condition, etc. And on the next page, you can see how we would set up this with CypherDSL. So the query itself, it's a little bit more. It might not be the best example for CypherDSL easy usage, but it shows you very verbose how we construct certain parts. And the interesting bit is not that you can create person nodes, etc. We can then create broader objects like a relationship, where we put in a person node that is related with a movie node. We can then put around the match statement. Then we have the match with the condition. And then finally, we do the return clause. And as you can see, those patterns those parts can be reused. This is even more beneficial if you're doing the creation of statements. If you're doing those creations dynamic, so depending on some conditions and similar. So you can extract some parts, add some parts, or leave out some parts. And in the end, we built the statement to have something runnable for the driver. So it's the same query, or the same code that we had before, but instead of pure Cypher, we throw in the statement and want to generate the Cypher. Apply the additional parameter to the query, send it over to the database, and we get the same amount, the same result, okay, with the same amount of movies that you've seen before. Sorry. So this is something where you write applications, where you maybe try to do your first steps with Neo4j. But something Neo4j did not provide officially, there were some approaches, some libraries, was the JDBC driver. So you might be also still using your database tools, your experience with the use of JDBC. And now it's possible to use also JDBC with Neo4j on the protocol level. So we have an minimalistic implementation of our communication layer and values mapping right in the JDBC driver. So it does not depend on the whole driver anymore. It just takes over the communication part and translation part or conversion part. And with this, you can execute your Cypher statements via a JDBC driver. This is nice because you can use your tools that you are used to be used as Neo4j browsers, but it can also translate SQL to Cypher. This came with a joint venture with the inventor of the Juke library that is about the same as the CypherDSL is for Neo4j, was for Cypher. So both libraries can create an abstract syntax tree. And where those libraries meet, they can then interchange what is the same meaning of this block or of this part of the query, and then it can just to just be translated back and forth to SQL. So you could also write SQL. You see this in a bit. And why is this important and a big deal? It's because now it's also possible to use Neo4j in ETL tools that are only focused on SQL. Most of those tools are, if you don't want to come up with your own implementation of a plugin or similar, right? So we can throw in the driver, you can automate those functionalities. And yeah, to show you this, I just used dbweaver as an SQL tool. It's of course not ETL, but yeah, we can execute this Cypher statement. But the nice part is that I can also write with some configurations SQL, and I will get those results back. All right, and I can, of course, you can use the driver also as a library, right? So here you see the very same example that we had before, but it's parameterized. So it looks like a JDBC SQL query, but the Cypher, cool. I can add parameters to this, I can execute it. But I can also use this native SQL function to then translate SQL to Cypher and then create a prepared statement to provide the parameter, execute it, and both come to the same conclusion if I execute them one after each other, that we still find our actor with the 3 movies. And if you see something that you want, but that it does misbehave, or your ETL tool might fail because of some SQL clause it generates, you can open a ticket on GitHub, ask question in the community forums, Discord. So we are happy to get your feedback on this. Something I already mentioned this, we developed, I think it's 5 years ago, the new version of Spring Data Neo4j. But this was also about the time where test containers got a massive bump. So test containers is something like this. It helps you foremost with orchestrating your Docker containers, or starting and orchestrating them for the usages and tests. So you want to have a clean state to run it, for example, or some prepared data that's always the same, and you want to ensure that it's running with this data set that you know that is there. You don't want to use another colleague's machine to share data in your tests or similar. Foremost, if you're modifying data within your test suite. And around 5 years ago or something, we started then with the development of Neo4j test containers. So of course, you could have used Neo4j in test containers before this, but it would be a generic container that's not aware of anything Neo4j-ish. But with this concrete implementation for Neo4j, we can now provide some functionality like providing admin passwords, provide random admin passwords, because it's for container execution. We can enable some plugins that you can also enable via environment variables. And with such a test container, although most of the time you're using it in tests, but only to show this here, we can then get those informations from the container that we are really interested in. We want to create a driver connection, so we need to get the boat URL. We need to get the admin password if we have a random password, at least. So the only orchestrating bit I now do for this procedural function is to start the container and stop the container in the end. And yeah, the function ensures that it's running by just returning something from the empty database. And that's what I got. That's what I got back. So it's easy to set up. It has the Spring integration, so you don't even need to care about this orchestration bits anymore. As I already said, you have this clean test environment, and still experimental. You can have reusable containers. That means that it does not only always spin up new containers. That's pretty helpful if you have a lot of test classes. Yep. And before we come to the end, there's more. We have OGM, as I mentioned earlier. So even though this prominent example for object mapping in this talk was Spring Data Neo4j, and we have a lot of integrations with the Spring systems, with the Spring frameworks, libraries, we still maintain Neo4j OGM. So if you have Java-only application, for example, or you don't want to have Spring Data, you can still get object mapping via Neo4j OGM. Neo4j migrations, it's somehow like Flybase. So if you know Flybase, it has multiple approaches to define schema evolutions and your database evolutions in general. So you get migration scripts that get applied before every start. And this is also nice to be used with test containers, for example, if you want to get your test setup correct. And then there are some further Spring ecosystem projects we are involved with. One is Spring for GraphQL. This has a Spring Data Neo4j integration. So that's good when you have something like Spring Data as a general interface project. So we just needed to implement the requested method by Spring for GraphQL. And now you get GraphQL support out of the box for Neo4j if you use this library. Also, we did some handwritten queries, more or less, for Spring AI. So there is to use Neo4j as a vector store. It's built in Spring AI. And if you're interested in domain events and modularization of your application, there is also a Neo4j module for Spring modelers. And I am pretty sure that I missed some things where we also contribute to, but those are the current prominent examples that you can use. And if you're missing something, I always repeat myself, I know, but feel free to reach out to us. We are this close to you. So I would be happy to get your feedback on one of those libraries. But if you were just bored and clicked on the link for my talk, but you're not using JVM, there's something more. We have this new query API. So it's an HTTP server in Neo4j. It will be available also in Aura, or is already. So the good thing on this is that it's human readable and it's machine readable. Of course, every human readable piece would be also machine readable, but in this case, you get something more exclusive for machines, that you get all the type informations, etc. And the new Neo4j query API also has the feature that it behaves nice in clusters. So that really, if you say my intention of this query is a read-only query, it will get through the read replicas, and not always one on the on the writer node. And that's it. I don't know if there are any questions.